Right. So on today's notes, we're looking at Pascal's triangle and expanding binomials. So this is the initial layout and the triangle that you're going to want to copy down. And this is actually pertaining to the coefficients that you're going to use for each term when we actually go and expand these binomials over here. And obviously I'd look at that later on in a moment. But to be able to explain this, basically this says that anything raised to the power of 0 is going to automatically give you the number 1 regardless. From there, as the exponents increase and change, this actually allows you to identify what the coefficients will be for each term when you actually went and multiplied, aka expanded, this binomial out. So when you took a plus b times a plus b times a plus b, and when you did all the multiplication for it, you will find that these will be your coefficients of the 4 terms that you have when it's all said and done, and etc., etc. And one thing that you'll note, hopefully with the pattern, is basically ones go all the way down the outer edge on both sides. Now I got a little spaced out, but it's there. And then from there, it's actually a sum. So 1 plus 1 gives us 2. 2 plus 1 gives me 3. 2 plus 1 gives me 3. 3 plus 1, 4. 3 plus 3, 6. 3 plus 1, 4. And etc., etc. 6 plus 4, 10. 6 plus 4, 10. 4 plus 1, 5. And that would extend indefinitely regardless of what your exponent is. And so each one of these pertains directly to the row across from it. So if you had a binomial that's raised to the 4th power, then this is the row that you're going to look at to be able to identify the coefficients, or number in front, of each one of your terms. So let's go ahead and look at this at the next component when it comes to expanding our binomials. So the second step is to acknowledge that the exponent, which is going to be noted as basically n, all of these guys over here, is going to be the exponent of the first term's a. Right? And b will have the exponent of 0 for our first term. The next step that you're going to do is all following terms will have the pattern basically of your n minus 1 for your a, and b is going to start off at 0 and add 1, add 1, add 1, and add 1 to each one of its terms as it progresses across. So let's look at this. So we have number 1. Go ahead and scoot this up. And so we had a plus b raised to the 4th power. So we go, okay, so according to our chart, the 4th power has 1, 4, 6, 4, 1 is going to be our coefficients, And so if you see, we have a 1, 4, 6, 4, and 1 are in fact our coefficients for each one of these terms. The n, which is our exponent of the binomial, is going to be the exponent of the a of our first term, and b has an exponent of 0, which basically means it's 1. So it doesn't really exist. You don't have to include it. You can if you want to. And then from there, each one of my a's exponents are going to decrease by 1 until a is 0 and it basically disappears. B, on the other hand, is going to be B1, B2, B3, and B4, and increase for the duration. And that's it. You don't have to do any actual multiplications. You do not have to write this out and multiply, 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 multiply. You can just say, whoop, there's my coefficients. Here's my exponent of my a, decrease it each term, and b increases each term, and I'm done. So let's look at this as another example. So what if you had it raised to the 6th power? Okay, according to the triangle, those will be my coefficients. I'm going to use my exponent here to be my same starting exponent here. It's going to be decreasing, so it goes from A6 to A5 to A4, 3, 2, and 1. And my B is going to increase from 0, 1, 2, 3, 4, 5, and 6. And you're done. That's what it would be if you expanded it out and multiplied these values to themselves 6 times. So our last example kind of combines two different elements that you might see. And what happens when we have a negative, and then what happens when we have actual number in either one of these components. So in this situation here, my b is actually -2. So basically, wherever there was a b, you think about putting parentheses around it and put -2. Parentheses around it, -2, etc., etc. So that's what we have down here. I have my coefficients, 1, 3, 3, 1. I have my decreasing a, which in this situation is an x until it disappears. And then my b, which is -2, goes from an exponent of 0 to an exponent of 1 to an exponent of 2 to an exponent of 3. So then from there, you are all multiplying. This is 3 times x squared times -2. So you'd multiply your constants together and get -6. Over here, make sure you square first before you multiply by the 3. And because it's a square, it turns it positive and you get positive 12. And then raise to the 3rd power, negative, and done. So a trick with these, if this is ever a negative, is that your signs are actually always going to go positive, negative, and so on and so forth regarding how many terms you actually have. So there you go. That is expanding your binomials, and I hope this helped.